Hi, my name is Serwaish. Recently I completed a certification course on sentiment analysis using Python, and here is the code for how this is done. In this video we will see only half of the code, so to keep this video short, I will soon bring the next half of the video. So let's start. Here are all the libraries that are required in this project. This block of code is used to decode the dataset files, separate the labels and text in the dataset file. Labels are 1 for positive review and 2 for negative review. If you want to download the file for this code, you can download from kaggle.com. This block is used to print the label at index 0 in train file that is decoded in previous code block. This block is used to print the text at index 0 in train file that is decoded in previous code block. These two blocks are used to update the label and text list to contain values from index 0 to 500. Now this block is responsible for all the text pre-processing like removing special characters, numbers etc. We will try to go line by line in this block as it is a necessary block. This code block demonstrates a function named normalize_texts that takes in a list of texts, text normalization on each text. The purpose of text normalization is to pre-process the texts and make them consistent and uniform for further analysis or processing. Here's a breakdown of the code. 1. Import re. This line imports the re module, which is used for working with regular expressions. 2. non_alphanum equals recompile r\w. This line defines a regular expression pattern using the re function. The pattern \w matches any non-alphanumeric character. It will be used to remove punctuation marks from the text. 3. non_ASCII equals recompile r *a z0-1 \s. This line defines another regular expression pattern. The pattern *a z0-1 \s matches any character that is not a lowercase letter, digit, or white space. It will be used to remove non-ASCII characters from the text. 4. Definite normalize_texts, texts. This line defines the function normalize_texts that takes in a list of texts as a parameter. 5. Normalized_texts equals, this line initializes an empty list to store the normalized texts. 6. For text in texts, this line starts a loop that iterates over each text in the input list. 7. Lower equals text.lower, this line converts the text to lowercase using the lower method. This step helps ensure case-insensitive normalization. 8. No_punctuation equals non_alphanum.sub r lower. This line uses the sub function from the re module to substitute any non-alphanumeric character in the lowercase text with a space character. This step removes punctuation marks from the text. 9. No_non_ASCII equals non_ASCII.sub r no_punctuation. This line uses the sub function again to substitute any non-ASCII characters outside the range of lowercase letters, digits, and white space, with an empty string. This step removes non-ASCII characters from the text. 10. Normalized_texts.append, no_non_ASCII. This line adds the normalized text to the normalized_texts list. 11. Return normalized_texts. This line returns the list of normalized texts. 12. Train_texts equals normalize_texts, train_texts. This line applies the normalize_texts function to the train_texts list, storing the normalized texts back into train_texts. 13. Test_texts equals normalize_texts, test_texts. This line does the same as the previous line but for the test_texts list. Overall, this code block provides a way to normalize texts by converting them to lowercase, removing punctuation marks, and removing non-ASCII characters. The resulting normalized texts can then be used for various text analysis or processing tasks. This block prints the train_text at index 0 after all texts are normalized. That's it for this video. We'll soon bring next part. Thanks for watching. Please like this video and share with others.